36, you are asked to find the zeros. The zeros, if you can factor, finding the zeros become much easier. Sorry for the readjusting of the camera. It changed my view even after I pressed play. Okay, we're good. So if you can factor, you just set each factor equal to 0.
Just cross out all the.
The question I have is, how do we factor? Well, this problem already has multiplication, which means it's partially factored. Okay, so we're actually going to be pretty close to being able to set this thing equals to 0. And as why did I change that to a third? No idea.
Zeros in the first one, so I think it'll probably be in the second one too. Or one of the things you have to put like x.
And actually, if you wanted to, right now, you could set the 1/4 x to the third equal to 0 and the x squared minus 9 equal to 0 and keep solving from there. So they did some of the work for you. This problem is actually easier than most of the ones I did for you on Tuesday. Okay? So 1/4 x cubed equals 0 and x squared minus 9 equals 0. This brings up a good point. You don't have to be linear factors in order to set your factors equal to 0. Set your factors equal to 0 whenever you can solve each of the factor equations, and that's okay. So like x squared minus 9, I could factor that further, but I don't have to. I can actually solve x squared minus 9 equals 0 by square roots, and that's fine. Okay, if you want to factor it more, you can. If you want to just set it equal to 0 and take the plus and minus square root of both sides, that's fine too. Yes, sir?
Yeah, the pencil. There's none over there, and all I have is the pencil mark.
So x squared minus 9 could give me x squared equals 9. And then if you take the square root of both sides, put plus and minus, you're going to get x equals plus and minus 3. If you factored x squared minus 9 to be x plus 3 times x minus 3, you'd get x equals negative 3 and x equals positive 3 from those. Okay? What about this guy? How do I solve that for x? Multiply by 4. Very good. Multiply by 4. And x cubed equals still 0. Careful, 0 times 4 is still 0. All right. Then how do you solve for x? Take the cube root. Very good. Take the cube root. So x actually will equal cube root of 0 is still 0. You don't need plus and minus on a root that is odd. You only need plus and minus on a root that is even. You probably know that, but I thought I'd say it. So like over here where we took the square root, you need a plus and minus. Where we take a cube root, you don't need plus and minus because odd powers preserve negativity. So if you had an odd root of a negative number, it would stay negative. Even powers don't preserve negativity. If you take a negative number and raise it to an even power, you're going to lose the negative out of it. That's why you need plus and minus with the even roots. Does that make sense?
That's also why you can't take the square root of the
It
number.
is. It is.
That makes sense. Because like negative 3 times negative 3 is 9, but 9
Right.
times negative 3 is technically half.
Exactly. Exactly. Okay. That's 36. Any other questions on Tuesday's assignment? Bless you.
I might have one. I'll look back to the one. Get my book. It was 42.
42. 4x cubed plus 4x squared minus 7x plus 2. And actually, I'm going to use this as an example of something that you should use what we're going to do today. Okay? At first glance, it looked like it was going to factor by grouping, but it actually doesn't. So 4x cubed minus or plus 4x squared? Plus 4x squared Okay, so I would try grouping this thing, but your foreshadowing probably could look at these two and say, if I factor out a 4x squared, I'm going to get x plus 1. I'm not going to get x plus 1 out of that. No way. So this thing does not factor by grouping, and we actually need the binomial theorem. Okay, so here we go. This is now going to be 4.3, and I'll come back to this problem as an example. Okay? Is that all right? Okay. All right, so I'm going to start a new slide here. 4.3 is on finding zeros. I am. I'm going to use it as an example.
Yeah.
2.3.
I was like, whoa, let's get
Yeah. We were doing problem number 42. I was thinking 4.2. Go.
So you put 4.3?
Yeah. It's supposed to be 2.3. My brain went to 4.2 as the question, even though it was 42. Call it 8 o'clock in the morning. Okay? So the first thing we need to do before we can find the zeros is review long division. Because you have to be able to do long division in order to do this. Okay? So I'm going to review long division with you in numbers first. I'm going to start way back in elementary school, because if I review it in numbers, reviewing it with polynomials usually is a lot easier for people. We're not going to spend a ton of time on reviewing the number one, though. So if you take 452 and divide that by 21, how do you do this? This is totally review. I understand that. How do you do long division? That's my question. Okay, 21 does not go into 4 because it's too many places. So 21 goes into 45 how many times? Twice. What do you do with that number?
Put the 2 at the top above the 5?
Put the 2 up top, and then you essentially multiply the 2 times 21. 2 times 21 gives you what? 42. Do you ever take 2 times 2 and 2 times 1 and then add them? Okay, think of it that way. 2 times 20 and then 2 times 1 and add them. Okay? So, right? Because it's different than how you used to do it, right? But that's essentially what you do when you're multiplying a 1-digit times a 2-digit. Is you take that thing times the first number and keep that number in tens, and then you take that thing times the second number and add them. Right? Okay. So, what do you do with the 45 and the 42?
Subtract it.
And you just know that you have to subtract. You always multiply and subtract. Keep that in mind, because that's a big deal. Do you just subtract the 4 and then add the 5 and the 2? Of course not. You subtract the 4s and you subtract the 5 and the 2. These are things that I see people change when they go throwing variables in there. Okay, so keep that in mind. You're going to subtract 4 and 4 and get 0. And you're going to subtract 5 and 2 and get 3. Now you have to bring down the 2, because 21 doesn't go into 3. Bring down the 2. Okay. 21 goes into 32. 1 time. What do I do with that? Put the 1 next to the 2 up top. Okay, then what do you do with the 1? Okay, so you're going to take 1 times 21, and you're going to multiply 1 times 21 and get 21, and then you need to subtract. And again, of course, you subtract the 3 and 2 and the 2 and the 1. Okay? Okay, gives you 11. What do we call 11? 11 is smaller than 21, and we're out of the original number. We would now have to put a decimal point, and here's where dividing with numbers deviates from dividing with variables. We don't know what to put if we're dividing with variables. So what do we call 11?
A remainder.
A remainder. Do you know what the remainder effectively does? No. You want to take 11 and divide it by 21, right? That's what you're trying to do. So guess what you do? You put 11 over 21 up top, and you probably were told in elementary school to put your remainder over your divisor. Okay, and there's nothing wrong with that. This fraction, 11/21, is what you're finding when you carry down decimals and keep going. You're finding a decimal for 11 over 21. Okay, but writing it as 21 and 11/21 is totally fine.
Could you just put R11?
We're not going to do that because this 11 over 21 is actually how we're going to apply it to polynomials. All right, ladies, you with me? Yes, no, maybe so. No? Yeah, well, he was, I didn't think he was talking, maybe he was.
Jeremy, you're a lady. Even though you felt backwards.
So 6x to the third. This is this is not, we're not ready to do that yet because we don't know what to divide by. I've got to tell you how to come up with what to divide by, but first we have to talk about how to divide first.
Why is it cold in here now? Because this is the funny thing about furnaces.
6x to the third minus 19x squared plus 16x minus 4. I want to divide that by x minus 2.
Is this all the unit is right here?
No. No, we have to apply this. Some questions will say divide this by this. And yes, that's important that you know how to do that. But some questions will say find the zeros. That's the culminating goal. You want to be able to find the zeros. You can't do it without knowing how to find the possible factors, which you have to divide by to find out if they are factors. Is 21 a factor of 452? Why not? Because it has a remainder. What do I need the remainder to be in order for 21 to be a factor of 452? 0. So you're going to keep that in mind. When you're long dividing, if you come out with a remainder of 0, you have found a factor. Okay? So all of these things are now going to be applied here. Let's do the problem. How do I divide x into 6x cubed minus 19x squared plus 16? You start by just talking about the first terms in each of them. Really, the 20 mattered more than the 1. Okay? So the 20 didn't go into 4. 20 is bigger than 4. 20 went into 45. So did 21. Okay? So now we're going to talk about x. X is in the driver's seat here. The highest powered term in your divisor is in the driver's seat. Write it first. Okay? So if this were 2 minus x, or if this were 2 negative 2 plus x, I should say, I would rewrite it as x minus 2. Okay, write your highest power term first in both places, outside and inside. It'll make your life so much easier. Something else that'll make your life so much easier. Over here, if I had 402, I would hold the tens place with a 0. Do that here as well. If you're missing a type of term, like this one goes power of 3 to power of 2 to power of 1 to nothing. If you are missing one of those, hold it with a 0. So put plus 0x squared if there aren't any x squareds listed. That will make your life easier as well, generally speaking. Okay? Now let's start the dividing process. So I need to ask myself, x times what is 6x cubed? 6x squared. 20 times what is 45? 20 times 2 is 45. Okay? Gets me close. So x times what gives me 6x cubed? X times 6x squared gives me 6x cubed. After you figure out what to multiply by, you actually do the multiplication, and be sure to multiply 6x squared times this entire group right here. Okay? So you're going to take 6x squared times the x and the minus 2. When you do that, you're going to get 6x cubed. You should always get exactly what you just had for the first term. If you don't, you did something wrong. Okay? That's the nicer thing about polynomials. And minus 12x squared. Okay, but after we multiply, what do we need to do with those things that we just found?
Subtract.
You have to subtract. That blue subtraction symbol. Everything, and what that does is when you subtract, you change all your signs. So I'm going to take minus 6x cubed and plus 12x squared. You're subtracting the quantity. Okay?
Do you put parentheses around yours at all?
I do not. If you'd like to, go for it. I cut that step out because it's easier to tell people that you subtract this whole line, which means you go through and you change all your signs in this line. Does that make sense?
Yeah, I was just saying that's how I learned.
Go for it. Put the parentheses. There's nothing wrong with it. Okay? 6x cubed minus 6x cubed is going to give me 0, of course, and it should every time. Okay? Negative 19x squared plus 12x squared is going to give you negative 7x squared. Be very careful. Make sure you do your numbers right. Okay? Do your numbers right at the beginning and your backside's going to come out all weird. So minus 7x squared. I should probably drop down my plus 16x, and I'll tell you a secret, you could drop down the 4, right, the minus 4 right now also. There's nothing wrong with dropping down the minus 4. It just may not be affected by your next product. Okay, if you want to drop down all of what's left, that's fine. There's nothing wrong with it. Okay, we're ready to do this again. It's a good time for you to ask questions.
Oh, why was it 4?
Because did you subtract the 4 and the 2?
Oh.
You have to subtract this whole line. That's what Jared was saying about putting parentheses with the minus in front. If you'd rather do that, you can. Just make sure you subtract both of these things. Subtract everything in this red line. Does that make sense? What other questions do you have? Okay. If you come up with some, tell me. Let's try this again. So x, we're not done because x can still go into negative 7x squared. X times what gives me negative 7x squared? Negative 7x. So you put minus 7x up top. Then you need to multiply and subtract. So you're going to take minus 7x times x and times 2. Minus 2, really. When you do that, minus 7x times x is going to give you minus 7x squared. Don't worry, we're going to change the sign in a minute. Okay? Minus 7x times minus 2 is going to give you plus 14x. But then I not only have to multiply, but I have to subtract. So I'm going to go through and change all my signs. I'm changing this negative 7x squared to a positive and this plus 14x to a minus. All right? What happened? Gotcha. What are you left with? 2x. Drop down your minus 4 now if you didn't already have it there. Okay. Are you done? No. X times what gives you 2x? 2. So guess what? You put a plus 2 up top. Now multiply and subtract. Again, it's always a multiply and subtract pattern. So you're going to multiply 2 times x and 2 times minus 2. 2 times x gives me 2x. 2 times minus 2 gives me minus 4. Do not get too excited at the very end until you're absolutely positive that you get a remainder of 0. I've seen lots of people put like, oh, those cancel when they don't. Actually, like you have opposites to begin with, and then when you subtract, they turn out the same. So they don't cancel. So just make double sure that they do cancel, and here they do cancel, and you get a remainder of 0. Okay. No, dividing should not be the hard part. The division should be the easy part eventually. The hard part is coming up with the factors and going through the whole rigmarole of finding out, is this possible factor a factor? Do I get a remainder of 0?
So can you actually like factor
Okay, so what we just find? We just found out, I'm going to take this and just kind of run with it here for a second. Okay, so we just found out that x minus 2 is a factor of this guy in here. 6x cubed minus 19x squared plus 16x minus 4 equals x minus 2 times this guy up here.
So you're really gonna have 3 zeros.
Yes, you should have 3 possible zeros. Whether they are real numbers or not is a different question. Okay? And for a cubic, you should only have to do long division for one factor till you find one factor, because then after that you're left with a quadratic, and you can use the quadratic formula if you can't factor further. This one might factor further, we have to test it. Okay, so x minus 2, let's see, that's not what I wanted. Hang on. I don't know, I'll fix it. Camera's still there, and that's important. So I started off with 6x squared minus 19x plus squared plus 16x minus 4. That's what I started with. Okay? That is equal to x minus 2 times that thing times my dividend. 6x squared minus 7x plus 2. Hang on. We need to let this resonate with people for a second. This is what we just found.
That should be 6x cubed.
That's a 6x squared. You're right. It should be 6x cubed. I said it and I wrote it wrong, I think. Is that what you're going to tell me? Yeah, sorry. So this is what we started with, and this is now what we have. Because we have a remainder of 0, this turned out evenly. Is what we did, divided in evenly is what we might say. Okay? All right. So if your goal was to set this thing equal to 0, instead of setting this thing equal to 0, you can now set this thing equal to 0 and solve. That's where we're headed. Okay? Should we finish this problem? So now find the zeros. So what that means is that we're going to take 0 and set it equal to our factor form. We're going to set 0 equal to x minus 2 times the quantity 6x squared minus 7x plus 2. Now it's a game like we did yesterday. How do we solve this? Tuesday, rather.
Didn't you set both of those equal to 0?
Yes, you should. X minus 2 equals 0, and 6x squared minus 7x plus 2 equals 0. Okay, so x minus 2 equals 0 gives me x equals 2, obviously. One solution done. I know where I cross the x-axis. I cross it at 2. Do I cross it anywhere else? Well, I don't know. Does this thing factor further? Let's try it. All right. If it didn't factor further, I could use the quadratic formula because this is a quadratic. Okay. Let's see if it factors further. What are your factors of 6? 3 and 2 or 6 and 1? What are your factors of 2? I need a combination of these. So I'm going to take 2 times one of these, and I'm going to take 1 times one of these, times the other set, the other number in the set. And I need them to add to be negative 7. Well, if it has to add to be a negative, they both have to be minus inside the factors, right? Okay. 6 times 2 gives me 12, plus 1 gives me 13. That doesn't work. 6 times 1 gives me 6, plus 2 is closer, gives me 8. Darn. Okay, so 6 and 1 does not work. Let's check 3 and 2 both ways. So 3 times the 1 gives me 3, plus 2 times the 2 gives me 4. 3 plus 4 gives me 7. That one works. So I need to be taking the 3 times the 1 and the 2 times the 2. Things that are multiplied get put in opposite factor groups. It's like they play on opposite, it's like they guard each other on a basketball court. Okay, so 3x times the 1 has to go on opposite factor groups. They're on opposite teams. They're guarding each other. Okay, and 2 times 2, 2x, has to go in the second factor group. And 2 goes in the number position of the first factor. Check your inners and outers. That's what should total 7, negative 7. Okay, your inners and your outers, do they equal negative 7? Negative 4x, negative 3x. Yep, they equal negative 7. So we're good. We found the factors. This thing does factor further. So now 3x minus 2 equals 0, and 2x minus 1 equals 0. 3x equals 2, x equals 2/3. 2x equals 1, so x equals a half. Very good. How many zeros do you have? 3. You should always have 3. You should always have the same number of zeros, although they may not all be distinct. Okay, some of them may be duplicates. You should always have the same number of zeros as power that you started with. Now where'd my scrolling bar go? Spectacular.
On the other side.
Huh?
Press the arrow.
On the other side.
No idea how it moved over there. It was over there a second ago. Anyway, you should always have the same number of zeros as you have power in your original equation. Okay, so we have 3 zeros. They happen to all be real zeros. I mentioned that Tuesday. They don't have any i's. We don't have any square roots of negative 1. Okay? If this was all there was, I would give you some problems and you would try them. The problem is that I started you off with this guy. That's the problem. The problem for today is how do we come up with that x minus 2? Okay? So this is where we're headed. This is the big picture. First 27 minutes of class, and actually only the first 14 minutes of class because we'd spent a time doing a problem that was yesterday's stuff. Okay? But this right here is where we're headed. This is the end of every problem that asks you to find the zeros. The beginning is now what we need to talk about. Okay? Questions before we do more? I'm going to take a second and summarize exactly what we just did. So we need to find the factors. Find factors. Which means you're going to use long division. Until you find a binomial that gives you a remainder of 0. Okay, because once you find a remainder of 0 possible factor, you found one that is a factor. Okay? After you find factors, you're then going to set factors equal to 0. If you can factor further or any quadratics that you have left, you'll use the quadratic formula or continue factoring if possible. The one we just did happened to factor the rest of the way. If it didn't, I would just use the quadratic formula. Okay? Find the factors. Set factors equal to 0. Obviously, for linear factors where you just have x plus a number or x minus a number, you're just going to subtract or add the other side. Okay, so you will solve. You may need the quadratic formula. for any quadratic dividends is what we call those guys that we're left with up top of the division house. Okay, any quadratic dividends that do not factor, or that you don't feel like factoring. You can do that too. All right. So how many times do you have to do long division? That's usually what I get asked, because it's like, that took us a long time to do that long division. That took the longest. Okay, so how many times do you have to do long division? And the answer is you have to do it until you get down to a quadratic left. Okay, so if you have an x to the fourth, you may have to do long division at least twice. Okay, if you have an x to the fifth polynomial, you may have to do long division at least 3 times. Keep in mind that your first tests are, do I have anything in common that I can factor out? Do I have any other factoring techniques that apply? Like, does grouping work? Is it a quadratic in disguise? You want to check those things first before you test the things with long division, because it takes a lot longer. Okay, so keep Tuesday's stuff at the forefront of your mind. That's like your filter of what you run your polynomial through this filter first. If those things don't work, that's when you have to fall into long division stuff. Okay, so here you go. How do you find the factors? How do you find possible factors? This is how do you know what to test in your long division? Let me go back to the one I just gave you. If you have a polynomial 6x cubed minus 19x squared plus 16x minus 4. This is the one we just did. The possible factors come from the first and the last terms. Think about foiling. When you FOIL, you have your first and your last terms, factoring, I should say, with a quadratic. Your first and your last terms are your drivers. They're the numbers that you see. Okay, so you need to factor your first term and factor your last term. Factors. So my possible factors of 3 and 2. Factors of 4 are either this problem. Do you have to test them all? I can remember. I could have 6x plus 2. That's everything with a 6 as the first number. With a 1 as the first number. 1x plus 4. 1x. I could have 1x plus 2. And I could have 1x minus 2. What?
Okay. What exactly?
Okay. This is a long actually, but let's keep going. I could have 3x plus 4 and 2x minus 4. Might look at this group and go, I test is like what? So you only need to find one. Here's where you grab a buddy and you say, I'll test this